Good day, viewers. You are welcome. How to solve this algebra problem, quadratic radicals. Because this problem which says 2x plus 5 square root of x equals 3. So this is unlike the normal quadratic equation. Here is a radical problem, so which involves root x. So the way of solving this will be different, and I'm going to apply two approaches to solve this. I'm going to use two different methods to solve this problem. So let's see the first method. So suppose this is method 1. So if you try to let this root x equals y, we have root x equals y. So when we take the square of both sides, we have x equals y squared. Then we are going to replace it in the question, which is 2. Instead of x, we have y squared plus, and instead of root x, we have it as 5y minus 3 equals 0. So here is now a standard quadratic equation. 2y squared plus 5y minus 3 equals 0. So we are going to factorize this because it is factorizable. But what to do first is we multiply these two by 3. So it means what we have here is now 6, not 3. So we look for two numbers. When we add it, we get plus 5. And when we multiply that same number, we are going to get minus 6. And the two numbers are 6 and minus 1. So we try to plug it in this. We have 2y squared plus 6y minus y minus 3 equals 0. So we multiply these two by 3, which is 6. Not that the 6 will appear here, no. So we just use to multiply it to make sure that the coefficient of this one remain 1. So we cannot group this into 2, as here is 2y squared plus 6y. Then here negative is common, we take it out, and we have this as y plus 3 equals 0. Again, what is common here is 2y. We factor it out, and we are left with y plus 3 minus open bracket y plus 3 equals 0. So here we have 1. So here is y plus 3, and here is also y plus 3. We take one of these and we combine their coefficients together. So here we have 2y minus 1 bracket y plus 3 equals 0. And from this, we present to you that the value of y here equals 1 over 2, or we have y equals minus 3. And to get the value of x, when y equals 1 over 2 and when y equals minus 3. So we are going to recall from where we have root x equals y. And at y equals 1 over 2, so we have root x equals 1 over 2. By taking the square of both sides, we have x equals 1 divided by 4. But let's see the second part of this, which is when y equals minus 3. We have root x equals minus 3. But can we take the square of both sides? No, because this is a square root. It means that anything we have here must not negative. And what we have here is negative. So it means this solution is rejected, because what this one is trying to say is it is absolute of x, and the absolute of any number is always positive. Therefore, this x, which is negative 3, is rejected. And let's prove it using the second method to see that this negative 3 is rejected. So this brings to the method 2. We have 2x plus 5 root x equals 3. What to do is, when we transfer these two x to other side, here is 5 root x equals 3 minus 2x. And we take the square of both sides. 5 root x raised to power 2 equals 3 minus 2x raised to power of 2. Then 5 will take square and root x will also take square. When 5 takes square, we have this as 25. Then root and the square they cancelled. We have only x equals, so the expansion of this becomes 9 minus 12x plus 4x squared. So when we expand this is what we are going to get. So by collecting all these to one side, so the whole of this result becomes 4x squared. So when this 25 comes here, it becomes negative, and minus 25 minus 12, it gives minus 37x plus 9 equals 0. Again, we can also factorize this, because when we multiply 4 by 9, what we get is 36. We can take two numbers, which is minus 36 minus 1. So which are the number that when we add it together, it gives us minus 37, and we multiply it, it gives us 36. So doing that, we have this as 4x squared minus 36x minus x plus 9 equals 0. And with the whole of this, when we factorize it, we group it, we are going to have 4x bracket x minus 9 minus bracket x minus 9 equals 0. And again, we combine this and this together, and we take one of these. So therefore, we have 4x minus 1, or we have x minus 9 equals 0. So when we let this equal 0, we are going to have x equals 1 over 4, or we have x equals 9. But looking at this, it's different from what we have above. So we have x which is positive here. Yeah, we get x which is positive, but how are we going to know that this 9 does not satisfy the equation? Here is how we are going to do. So we check. So when we check for when x equals 9, in this, when we substitute it here, we have 2 multiplied by 9 plus 5 root 9. So obviously this is not equals 3, because 2 multiplied by 9 equals 18 plus 5 multiplied by 3 here, that is 15. And the addition of this is not 3, which means that at x equals 9 is not satisfy this. This is how to solve this problem. Thanks for watching, and please don't forget to subscribe to this channel for more exciting math content like this. I will see you in the next video. Never stop learning. Bye bye.